right, you guys, last lesson of the semester. Last thing you got to do for geometry. Relating arc length and area of a radius. Well, area to, arc length and area to the radius. Okay, so we're going to do arc length and area. There are formulas for this. I'm assuming that they're probably going to get us to, like, find the formula or whatever. So, who knows? Let's see. Let's see what they got to get us to do. All right, so I'm going to click on my GeoGebra for arc length. Okay, I don't have a grid or anything. I'm just seeing 3 points. That's all I'm seeing. Okay. Well, okay then. Create one circle with center A passing through B and another circle center A passing through C. All right, so I got to have 2 circles. All right, so I'm going to do circle with center 3 points. So I'm going to go A to B and A to C. Okay. So both of these circles have the same center. Circles with common centers are called concentric circles. Yes, they are. We'll refer to the circle that passes through B as AB, and the one that passes through C as AC. Besides being concentric, what's the relationship between the circles AB and AC? Well, they have the same center. They're going to be similar. All circles are similar, but I don't know what the radius is to compare how much it's been dilated. I don't know that. So I don't know. Other than they have the same center and then they're similar, that's what I can come up with there for right now. They have the same center, and all circles are similar. So that's all I can come up with for right now. Let's see what they say. Point of center. Well, there you go. Okay. They got the same thing I got. All right. Question 2. Make another construction by following these steps. Okay. Create a random point D on the circle that's AC. All right. So AC is this one because there's my C. They want me to have a D somewhere on there. So, boom, there's my D. All right. Construct the radii AC and AD. So that's our segment. So I'm going to come over to segment. Click on AC. And then AD. All right. So these are going to be the same lengths. They're both a radius. AC is a radius and AD is a radius. So I know they're going to be equal to each other. All right. Determine the intersection of AC. Determine the intersection of AC with circle AB and label this point E. All right, so hang on. I got to think about this for a second. The intersection of segment AC. Okay, so here's segment AC, and they want the intersection of this circle. They want me to label that point right there F. E. They want it to label it E. Okay. So I'm labeling this point right here E. All right, so I'm going to come up to point. Oh, let me go to intersection. Intersection. Boom. Okay, there's my E. And I assume they want this one to be F, but let me read. Determine the intersection of AD with circle B. AD with circle B, they want the intersection. So intersection, they want it to be labeled F. All right, got my intersection points. Okay, record the coordinates of E and F on circle B. All right, so they want just the coordinates. Okay. Well, let's see what we got. We don't have a chart. That figures. Okay. So let's see. I need to come up. Where can I find it here? Hopefully it's in my stuff. Talking to myself more than I am you guys. Ooh, show grid. Ha ha! Okay. Now I'm getting somewhere. All right, show axis. Show axis. Oh, okay, fantastic. Beautiful, beautiful, beautiful. I still need to know what that point there is. I can get E pretty good. It's just over 1 up 0. But F is a completely different issue. Look at the construction protocols and have it there. Oh, here it is. Can't see it very well. Oh, can I move that over? I can't move it over. All right, so E is 1, 0. And I had that one already. F is, it's an ugly decimal, 0.27, 0.96. Okay, fine. 0.27, 0.96. Okay. Is that all they want? Yeah, that's all they want. Okay. 10. Okay, the F will vary is what it says. So maybe your F and my F are not the same. Their F is this. My F is that ugly thing. Oh, yeah, that makes sense. Duh. Because, you know, you might not put your D right there. You might put your D way over here or your D way over here. Yeah, I got you. All right, so let me close this stuff up. Whoa. Let me undo. No! No! I lost my graph. Darn it. Well, okay, so, I gotta do it all over again. Dang it. Yeah, I was just trying to close it up, and that didn't work out so well. All right, let me get caught up with you guys. A to B, A to C. Gotta have a D. And I had it somewhere like right there. All right, so I gotta have a segment, A to C, A to D. And I had an intersection, and there was an E, and there was an F. All right, so, okay. So let's see here. Wait a second. Okay, question 3. Good grief. Select point B and drag it. As you drag B, circle AB changes. Okay. So I'm clicking B and moving it. Yes, it does. It just gets bigger. The radius gets bigger. Yeah. Okay, so the radius gets bigger. Circle gets bigger. What about it? Verify that you can make circle AB coincide with AC. Oh, well, yes, I can. Because I can just sit it right on top, and then boom, it's one circle, not two. Or I can put it right there, and now you see one circle. I can do that. All right, return B to its approximate initial position, and it's not going to be perfect. All right, so it was somewhere like right there. All right, when circle AB coincides with AC, what do you notice about the regions CAD and EAF? In terms of similarity, what does your observation imply about the relationship among the lengths of the radii? Well, they will be equal to each other. Of course, they're going to be similar. Circles are always similar. Relationship from the proportion. Explain how this follows your observation. Okay, first off, one thing at a time. A sub B. Let's talk about that first. Okay. Get off of that. A sub B. Okay. So that one can be mapped to the other one. What was it? A sub C. Okay. Which makes these circles similar. All right, we already know that one. I can't spell similar. All circles are similar. All right, now they want a proportion. Okay, so let's see. So the radius of AB, which would be either AF or AE because they're the exact same radius, would compare to AC because that was the original circle. A to B and A to C was the original circle. So the arc length of EF and the arc length of DC would be similar. So what they're getting me to do is set up the means to find the formula. So I see where they're going with this. Let me go to equation editor so I can show you what I'm talking about. All right, so this is going to be the radius of AB, that circle, to the radius of A sub C. So basically, I don't know if you guys remember the lesson. This is way before spring break. Right goes to the right, left goes to the left. It was height goes with height, shadow goes with shadow. If you were sitting in my class, you heard me say this over and over and over again because I was trying to get you guys to set proportions correctly. So radius goes with radius. All right, now arc length. And that's going to be of EF, because that's the small one. We'll go with arc length of the big one, which is DC. And I'm just going to hit OK to put that in. Let me hit that. All right, so I see where they're going with this. They're setting up the means to find their proportion or the answer. All right, use the proportion you found in question 3. Write an equation for arc length of EF in terms of the radius AB and AC and the arc length of CD. In other words, they want you to get arc EF by itself. Well, of course, the opposite of dividing by the length of the arc CD is to multiply this by the length of the arc CD. So let's see, we're going to have, oh gosh, I might probably use equation editor to do this correctly. Times, and that's going to be equals, and I need another, no I don't need another, I need an answer. Okay, so the opposite of dividing is to multiply, so I'm going to keep this, radius of AB divided by radius of AC. Now the opposite is to multiply, so this is going to be the length of arc CD. And we were trying to get the length of arc EF to itself, so now we have it. Length of arc EF. So again, they're just getting us to setting ourselves up for the formula. So in equation, in number 4, the equation relationships show the length of EF equal to AB, radius of AB. So for the given central angle, what does the length of the arc it intersects depend on? Depends on what the radius is. It depends on how long the radius is. That's it. It depends on the radius. Yeah, if the radius is big, like when I moved B, that radius got bigger. If I moved B, the radius got smaller. So it depends on what the radius is as to how big the arc length is. And watch this, you guys, especially if you're a visual person. That's right there is arc length. So if I move this B, watch this line right here. It just gets longer. And if I move B closer, then the arc length gets closer. It's going to get smaller. So that's all they're saying right there. That's basically the takeaway from this. All right. Cool. All right, so there we go. There's slide 6.